On Wednesday 1st of 2014 marked a great history in University Malaysia Sabah or UMS, where this institute became the first public higher learning institution to have a clock tower in its campus. The clock tower, reaching to a height of 9 meters, will be built in the middle of UMS roundabout and said to be a new landmark, the pride of UMS community. The Vice Chancellor, Professor Datuk Dr. Muhammad Harun Abdullah, when officiating at function, said that the UMS clock tower was a symbolic of the importance of time for intellectuals and the learned, and essential in calculating the discipline of time not only for students but also for staff of UMS. The UMS clock tower that was built is iconic 20th anniversary of the establishment of UMS. Starting from the inspiration of the fourth Vice Chancellor, it is translated and illustrated in artistic form and concept idea. The original concept design, produced by Suhaimi Latif, the JPP Senior Architect Assistant, then detailed and the construction process carried out through CSR by BHO Melati.
Now I will talk about the uniqueness of UMS Clock Tower in children learning. It has appealed to early childhood educators who want to adapt teaching and learning to children using the environment for geometric foundations. That is why the use of pictures, various shapes and building objects from shapes are necessary for children to learn from.
Now we are moving on to the introduction. STEM education fosters critical thinking and reasoning from an early age, laying the groundwork for lifelong learning. It promotes collaboration and knowledge sharing among educators and students, enriching their experiences. STEM skills, including critical thinking, creativity, and collaboration, are vital in today's job market, complementing 21st century skills like communication and literacy. Empowering students with these competencies prepares them to tackle real-world challenges and innovate solutions, fostering adaptability and competitiveness. So, what exactly is STEM or STEM? It is a global acronym for Science, Technology, Engineering, and Mathematics. Its teaching approach combining all the mentioned subjects through a hands-on curricular activity to ignite greater interest in science and math-related subjects among learners. And what are the benefits of STEM education for students? So the first one is enhance critical thinking skills, and next is prepare students for future careers, and improves technological literacy, promotes innovation and creativity. Next, focus teamwork and collaboration, and the last one is career readiness.
As you can see, the topic is Young Engineers UMS Clock Tower. Producing young engineers through UMS Clock Tower activity is essential to improve STEM education quality, advancing technology integration, and also preparing learners for demands of the future. That's why we need to use the ideal STEM lesson, which includes the first step is knowing the real-world issues. Next, identify the problem and do background research. After that, provide solution and of course, design the solution. When you already design, create the prototype and don't forget to test and evaluate so you can redesign back if there's something wrong with it. In this case, what is the real-world issue? From my level observer, their statement is about the impending impact of a technological revolution on various aspects of human life. Essentially, it highlights the belief that we are on the brink of a revolutionary change driven by technological advancements that will reshape society in ways previously unimaginable. Now we identify the problem. As you can see, Malaysia is ranked 51st out of 81 countries in the PISA study, especially in the subject of science, mathematics, and English. In fact, we are the worst among the 7 ASEAN countries. We move on to the background research. Sabah are working hard to get students interested in STEM subjects, says Hajiji. And in learning basic geometry, simply recognizing simple shapes is not enough. Move on to the next point. The Young Engineers UMS Clock Tower is an innovative approach in developing young children's informal engineering skills through the use of UMS Tower as instruments for assessment. This activity focuses on the handful of critical aspects of engineering identified from the literature review. Now it's the time for the design the solution. So this is the design, and this is after we create the model using the design that we provided. Next step is test and evaluate. In this case, we need to ask the children to try the design that we prepared.
originality/novelty. First project-based module using UMS Clock Tower as an outdoor learning eco-environment. Learning and communicating enhanced engineering skills through this module. Young Engineers UMS Clock Tower as an outdoor learning eco-environment for young engineers achievement among preschoolers has an instructional book that anyone learn how to learn engineering skills using project-based approach, has different activity which will ensure children master engineering skills, has guidebooks and references that will explain aspects engineering skills that are integrated with the use of simple technology. Project-based module using UMS Clock Tower as an outdoor learning eco-environment for young engineers achievement among preschoolers. The first one is preschoolers can learn engineering skills by using play-based module and simple technology integration. Children will learn engineering terms and language and think critically to produce the construction of the UMS Clock Tower. The Young Engineers UMS Clock Tower are designed for learners to apply engineering skills learned in classroom, incorporating simple technology and engineering elements, developing creative and innovative real-world solutions, solving real-world problems through a minds-on and hands-on activity. The outcome is develop learners' engineering skills as well as to enhance their skills in problem-solving abilities, computational thinking, design thinking, creativity, communication, collaboration, data literacy, and computer science. Through the UMS Clock Tower, children can be exposed to a little introduction to engineering. Children will learn about who designed and built the UMS Clock Tower. Children learn the design process step by step through the activity of building the UMS Clock Tower, which was produced from various shapes. This is a way to sharpen children's critical thinking. Next, we will be talking about the relevance of the invention of Young Engineers UMS Clock Tower. So the first one would be meeting the demand for STEM education. As the demand for STEM education increases, there is a growing need for more qualified STEM educators who can teach these subjects effectively. By producing more young engineers can help meet these demands. And the second one is improving STEM education quality. Young engineers through UMS Clock Tower require specialized skills and knowledge that many traditional educators may not possess. By producing more young engineers, we can improve the quality of STEM education and provide students with the best possible learning experience. The third one is technology integration. Young engineers through UMS Clock Tower help advance the integration of technology in education, which is critical for preparing students for the demands of the 21st century workforce. Next is fostering innovation and creativity. Young engineers through UMS Clock Tower can encourage innovation and creativity in students by introducing them to new tools, technologies, and approaches to problem solving. And the next one is promoting equity and access. Young engineers through UMS Clock Tower can help promote equity and access to high-quality STEM education by providing students in underserved communities with the same opportunities as those in more affluent areas. And the last one is meet current needs. Young engineers through UMS Clock Tower meet current demands for increasing the size of the local engineering workforce. Now we are looking at the pieces of origami that could be used in building the UMS Clock Tower. The series of this section starts with a 2-piece game and continues with a 3, then a 4-piece game. At each stage, the child is asked to fix the pieces of paper, which means rebuild the original square to make a shape with the pieces and to say whether or not they can name the shapes that they make. The app is an interactive educational tool designed to teach children about shapes in a fun and engaging way. It features 2 mini-games and a learning interface. The learning interface is immersive, combining interesting pictures and audio to help children grasp the concept of shapes effectively. One of the mini-games focuses on reinforcing children's understanding and memory of shapes, while the other challenges them to solve puzzles by arranging shapes into specific complex forms, such as house. Overall, the app provides a comprehensive and enjoyable learning experience for children to explore the world of shapes.
Engineering is skill in play. First of all, we need to understand and support children's explorations and competencies. When children involved in this practice engineering, they engage the reasoning and problem-solving areas of their brains in a dynamic way to observe, investigate, analyze, and solve problems.
The language of building. While building with the UMS clock tower, young children can make observations, measurements, and comparisons, record observations, thoughts, and ideas, build arguments with evidence to support their claims, and read and communicate information. New vocabulary that describes materials such as balance and supports can be introduced during the child's exploration, according to Gomez, Swipe, 2015. The introduction of a word depends on the student's needs and relevance experience and whether it will add to the student's understanding. Through the UMS clock tower, children can use language such as semi-oval, octagon, layout, and so on.
Now is supportive spaces and materials. Outdoor learning environment for early achievement of engineering skills among preschool children allow us to support children's critical thinking in a more exciting way. And this application is a combination of camera. Also, simple technology consists of accurate real objects. Learning outside the classroom can improve a student's academic performance and can reduce stress levels. UMS Clock Tower is an innovation that combines learning inside and outside the classroom that benefits students and teachers. It creates a relaxed environment for communication about educational discussion and flexibility for movement. We need to use the engineering process to make sure the children knows what they are doing. The first step is ask, and then imagine, plan, create, and lastly improve. Next is construction or engineering skills observed in play. There will be 9 points in total. The first one is sizing, second is strong base, and then loading, another point is stacking, and there's aligning.
Next, I will be continuing with squaring. Through the activities of cutting various shapes in the UMS clock tower spreadsheet, children will learn the aspect of squaring. And the next one is cornering. From the UMS clock tower video, children will see the design of the UMS clock tower from a 360-degree angle and can see the UMS clock tower from different angles. The next one is bridging and using fasteners. While building the UMS clock tower, children will learn about joining paper using glue to create shapes. And the last one is covering area. While building the UMS clock tower, children will arrange the construction layout of the UMS clock tower in the correct order and produce a square shapes instead of a triangle shape. The language of building. Children are communicating. Children discuss buildings similar to the UMS clock tower and express the shapes seen from the UMS clock tower. The language used by children includes the words used by engineers, such as the words balance, design, semi-oval, octagon, layout, triangle, and so on. Incorporating engineering activities into early learning education encourages children to see and think differently while developing their soft skills, shows them how to combine or transform previously acquired knowledge to come up with new and creative solutions. Now, let's discuss on what are children communicating. So the first one would be experience. The children will discuss and tell their experiences about the building that is very similar to the design of the UMS clock tower. Next is idea and plans. While building the UMS clock tower, children will plan which parts need to be completed first to make the construction process easier. And the next one will be concepts. While watching the UMS clock tower video, children will discuss and identify the concepts applied to the UMS clock tower. And the next one will be skills. Children discuss the correct way to cut the UMS clock tower spreadsheet. And feelings. Children express excitement while watching the video and while making the UMS clock tower. And the next one would be preferences. When cutting, gluing, and building UMS clock tower, children discuss and identify which parts should be given priority. And the last one is imagination. From the UMS clock tower spreadsheet, children will imagine the way and result of the construction of the UMS clock tower. So tying it together, where are they in the design cycle? So the first one is ask. Children discuss how to build the UMS clock tower. And imagine. Children identify the appropriate steps and ways to cut and build the UMS clock tower. Plan. Children discuss the steps and arrangement of the UMS clock tower designs. Create. Children deduce the correct way to lay out the design of the UMS clock tower. And The last one is improve. The children rediscuss the correct way to produce a strong and stable UMS clock tower.
What are the supportive spaces and materials for this project? First of all, it consists of non-standard that will talk about the price and quality, and next is varied materials that we use. Other than that is inspiration from the UMS clock tower, and then we have predictable spaces, and lastly, easy access.
Now moving on to the last point, which is learning standards. So the first one is membanding dan membezakan objek-objek yang mempunyai dua ciri yang sama. Yang kedua, mengumpul objek mengikut ciri yang dikenal pasti. Yang ketiga, mengukur panjang atau tinggi objek menggunakan dua atau lebih unit, bukan piawai. Yang keempat, memadamkan objek berdasarkan warna, bentuk dan saiz. Yang kelima, meletakkan objek pada kedudukan tertentu. Yang keenam, menggunakan kemahiran motor halus melalui aktiviti yang melibatkan alatan. Dan yang terakhir, menghasilkan binaan kreatif.